For this question, we want to sketch the graph of y equals 1/2 x cubed by plotting points. So when I plot points, I'm going to choose values for one variable and find the values for the other variable. The way that this question is written, y equals 1/2 x cubed, it's easier to choose values for x and then find the values for y. I'm going to choose just a standard set of x values, -2, -1, 0, 1, and 2, and substitute that into the equation. So that will give 1/2 times -2 cubed. And when I simplify this, I should follow order of operations, applying the exponent first. -2 cubed is -8, and half of -8 is -4. And that gives me an ordered pair of -2, -4. I'll do the same thing with all of the other x values I've chosen. 1/2 times -1 cubed equals 1/2. Apply the exponent, -1 cubed is -1, and half of -1 is -1/2. So we have the ordered pair -1 and -1/2. And we have 0, 1/2 times 0 cubed is 1/2 times 0, which is 0. So we have the ordered pair 0, 0. Then for the x value of 1, 1/2 times 1 cubed, we'll apply the exponent first. 1 cubed is 1, and half of 1 is 1/2. So we have the ordered pair 1, 1/2. And finally, we have x equals 2. That's 1/2 times 2 cubed. So 1/2 times 8, and half of 8 is 4. So we have the ordered pair 2, 4. So I have this list of ordered pairs, and I'm going to plot these ordered pairs. And as we plot them, a pattern should emerge, and then we can sketch the curve, sketch the graph of this equation. So we have -2, -4, -1, and -1/2, 0, 0, a half, excuse me, that one is incorrect, 1 should be 1.5, and 2, 4. So this gives me a sketch of the graph. If I connect these points and follow the pattern. So here we have the graph of the equation y equals 1/2 x cubed, and all of the ordered pairs that are on this line will provide solutions to that equation. On this question, we want to find the x and y intercepts of the graph of the given equation. The equation we're working with is 4x minus 7y equals 12. So first, let's try to find the x-intercepts. When you're looking for x-intercepts, you're going to let y equal 0. And that's because the definition of an x-intercept is that it's where the graph crosses the x-axis. So if you think about your coordinate plane, all of the ordered pairs that are on the x-axis are all ordered pairs that have the y-coordinate being 0. So an x-intercept is defined as a point where the graph crosses or touches the x-axis, and all of the points on the x-axis have a y-coordinate of 0. So if we substitute a y of 0, we're going to be able to find any value of x that is on the x-axis, and that gives us the x-intercepts. So we have 4x minus 7 times 0 equals 12. 7 times 0 is 0. And we have 4x minus 0 is 4x. I'll divide both sides by 4, and that gives x equals 3. So x equals 3 is the x-intercept. Sometimes we like to write these as ordered pairs. If we write it as an ordered pair, it would be 3, 0. So then we want to find our y-intercepts. So it has a very similar definition. A y-intercept is where the graph crosses or touches the y-axis. When we look for y-intercepts, we're going to let x equal 0. So once again, let's think about that. We have our coordinate plane. The definition of a y-intercept is any ordered pairs where the graph crosses or touches the y-axis. The y-axis is this vertical axis. And if we think about the ordered pairs that are on top of that y-axis, all of those ordered pairs have an x-coordinate of 0. So we can find those y-intercepts by letting x equal 0. So in our example, we would have 4 times 0 minus 7y equals 12. 4 times 0 is 0. 0 minus 7y is negative 7y. We're going to divide both sides by negative 7, and that gives y equals negative 12 over 7. So our y-intercept is negative 12 over 7. We'll write that as an ordered pair. And that's 0, negative 12 over 7. So we have our x and y intercepts of this given equation. On this question, we want to find the equation of the line passing through the points negative 3, 5, and 4, 5. Write the equation in point-slope form, slope-intercept form, and standard form. So we're going to need quite a few formulas to work through all the steps in this problem. So first of all, we need to find an equation of the line passing through these points. And we want to write the equation in these different formats. So let me write out what these different formats look like. Point-slope form is when you have y minus y1 equals m times x minus x1. The m stands for the slope, and x1, y1 is a point on the line, and so that's where this format gets its name from, because you need a point and a slope to use this form. Slope-intercept form is y equals mx plus b. M is the slope, and b is the y-intercept. And so you would need the slope and the y-intercept to use this form. And then finally we have our standard form. Our standard form is when you have x and y terms on the same side, so ax plus by, and then a constant on the other side. So when we're looking for an equation of the line, we want to find the equation of the line. We like to start with point-slope form because it requires us to have a point and the slope. Now we do have a point here, but we don't have the slope. But there's another formula that we have in order to calculate the slope. It's a formula to calculate the slope when you have 2 points on the line. So that formula is m equals y2 minus y1 over x2 minus x1. So x1, y1 would be 1 point on the line, and x2, y2 would be a second point on the line. So we have 2 points. We're able to calculate the slope. Once we have the slope, we'll be able to find the point-slope form of the line. So let's start by calculating the slope. Our points are negative 3, 5, and 4, 5. So I'm going to assign the first point to be x1, y1, and the second point to be x2, y2. Now I'll substitute these into the formula for slope. So y2 minus y1 over x2 minus x1. I get 5 minus 5, which is 0. In the denominator, that double negative becomes a positive. That's 4 plus 3. 0 over 7 is 0. So we found the slope of this line to be 0. Now when the slope is 0, we have a special kind of line, which is a horizontal line. So now that we know we have the slope, I'm going to use point slope form, y minus y1 equals m times x minus x1. And I'll use the slope that we just calculated. And it doesn't matter which one of these points you use. I'm going to use this one right here, -3, 5. You can use either of those points though. So we have y minus y1, which is 5, equals m, which is 0, times x minus x1, which is -3. We're going to simplify this just a little bit. On the right-hand side, 0 times anything is 0. And so we get our point slope form of this line to be y minus 5 equals 0. Then we want to write our slope-intercept form. So let me just label this. This is our slope-intercept form. And we want to now write this in, I apologize, I labeled that incorrectly. That is our point slope form. So we have our point slope form, and we want to write it in our slope-intercept form. Now in slope-intercept form, you have y equals. So that's what I'm going to do is I'm going to rewrite this equation to have y equals. So I'm adding 5 to both sides to give myself that y equals format that we see in slope-intercept form. So now you've rewritten this in slope-intercept form. And finally, we want to write the standard form. And the standard form is when you have both x and y terms on the same side and the constant on the other side. Well, you can see because there are no x terms, we already have that format, the x and y terms on the left-hand side and the constant on the right-hand side. So this is the standard form of the equation of this line, passing through -3 and 5, -3, 5, and 4, 5. On this question, we want to evaluate the function f of x equals x squared plus 5x plus 8 at the given values of the independent variable and simplify. We want to find first f of 4, then f of x plus 9, and f of -x. So let's start with part A. And we have our function f of x equals x squared plus 5x plus 8. And in part A, we want to find f of 4. So you'll notice that inside the parentheses, we're labeled f of x. That's for the variable that we're using. And f of 4 is telling us what to substitute in for that variable. So every time we see x, we want to change that to a value of 4. This is 4 squared plus 5 times 4 plus 8. And we're going to follow order of operations to simplify. 4 squared is 16, 5 times 4 is 20. And we can add The 16 plus 20 is 36 plus 8, and that will be 44. So f of 4 is 44. Then in part B, we want to find f of x plus 9. This time, the expression inside the parentheses is not just a number, it's an expression, x plus 9, but the process is still the same. This is still indicating what we want to substitute in for these x's that we have up here. So we could write that out as x plus 9 squared plus 5 times x plus 9 plus 8. We're going to simplify x plus 9 squared to be x plus 9 times x plus 9. So that's applying the exponent. The exponent of 2, we multiply the base twice. I'll use the distributive property with this 5 to get 5x plus 45. Carry down that plus 8. I need to multiply out the x plus 9 times x plus 9. That's x squared plus 9x plus 9x plus 81. Carry down that 5x, and 45 plus 8 will be 53. Then I'm going to combine some like terms. We have like terms of 9x and 9x and 5x. I carry down the x squared. 9x plus 9x is 18x, plus 5x will be 23x. And then I want to combine the like terms of 81 and 53, and that will be 134. So f of x plus 9 is x squared plus 23x plus 134. Finally, we'll do part C. In part C, we want to find f of negative x. So once again, we have an expression inside of this parentheses, and that's the expression we want to put in place of our x's. So if we do that, we would get negative x squared plus 5 times negative x plus 8. We'll simplify. Negative x squared means negative x times negative x. On the next term, a positive 5x times a negative x will be minus 5x. Negative x times negative x, negative times a negative will be a positive, and x times x will be written as x squared. So f of negative x is x squared minus 5x plus 8. On this question, we have the statement for what value of x is g of x equal to negative 9. For what value of x is g of x equal to negative 9? So we have to remember symbolically that g of x represents the y value. So this is saying for what value of x is y equal to negative 9? So we're looking at our y scale at a y of negative 9. It's right here. And I'm highlighting the line y equals negative 9. And I notice that right here we have a point where that ordered pair would have a y value of negative 9. So we want to know what that x coordinate is, and we can go up to our x scale and notice that that is 8. So for what value of x, that is 8, is g of x equal to negative 9? So g of 8 is negative 9. On this question, we want to use the vertical line test to determine if y is a function of x in the graph. So we have this picture, Looks like a parabola that's facing down. And the directions say that we want to use the vertical line test to determine if y is a function of x. Now, when an equation or graph represents a function, that means that every x corresponds to exactly one y. So for the definition of a function, every x corresponds to exactly one y. And we have this vertical line test because a vertical line is something that violates this definition. So a vertical line is not a function. We look at a vertical line and think about the ordered pairs that are on that line. Every single ordered pair would have the same x value. So let's say, for example, this is a vertical line at 2. Every single ordered pair would have that same x value or first coordinate of 2 with different y coordinates. So it might be -3, -2, -1, 0, and 1. So this vertical line violates this definition where you have an x coordinate that corresponds to one y coordinate. This is one x coordinate that has infinitely many y coordinates. So that's why we use this vertical line test to tell whether something is a function or not. So the vertical line test, what we do is we take our picture and we start drawing vertical lines on the picture. And when we draw the vertical lines, we pay attention to the intersection points with those vertical lines. If our vertical lines have exactly one y, then we have a function. But if it has more than one y, then it is not a function. So when we look at our picture here, all of the vertical lines that I drew only had one intersection point, one y value. And so that means that we have a function in this graph here of a parabola. So this graph does represent a function. For this function, for this example, we want to classify the given function as a polynomial function, a rational function, or a root function, and then find the domain. We want to write that domain in interval notation. So I grabbed this screenshot from one of the worksheets that I have so that we could classify these different types of functions. We've got the function g of x equals 2x minus 9, and the categories that we were given are polynomial, rational, or root. So I've got some very detailed definitions here, but I'm going to give you the really quick way of eliminating some of these categories. So for a rational function, you're looking to have a fraction. You're looking for something with a variable in the denominator. So you can see that our function, g of x equals 2x minus 9, doesn't have a variable in the denominator, so we can eliminate that category. And then the other category that's pretty easy to identify would be a root function. A root function will have a root or radical in it. So you can see down here, radical or root function, and we classify them with even index or odd index, but both of them you need to have a radical in your function. And you can see we do not have a radical in our expression here, so we can eliminate those categories. So that really only leaves us with a polynomial function. So it's easier to identify the other two categories, rational and root. Polynomial is a little bit more detailed. What you're looking for with polynomial functions, if you focus on the variable, that variable should be raised to a power that is a nice power. So if you look here, I've got a list of the nice powers. We call those whole numbers, 0, 1, 2, 3, or your counting numbers, 1, 2, 3, 4, 5. So the power on your variable needs to come from those nice numbers for it to be considered a polynomial. Also, you don't want to have any variables in the denominator like the rational. You don't want to have any variables in radicals or in absolute values. You want your powers to be these nice numbers here. So this is a polynomial function because the power on that x would be a 1. When we don't write a power, we assume it to be a 1. And when we're finding the domain of a polynomial function, let me zoom in on that just a little bit, there are no restrictions. We should be able to substitute any x value into the function, any real number. And so polynomial functions always have a domain of all real numbers. So the domain of this polynomial function is negative infinity to infinity. Classify the given function as a polynomial function, rational function, or root function. Then find the domain. Write the domain in interval notation. The function we're working with is h of x equals 8 minus 8t over 5t squared. So first we want to classify it in one of these categories. It's really easy to notice rational functions. They're going to have a variable in the denominator. And it's pretty easy to classify root functions. Root functions will have a square root in the expression. It might be square root or cube root, some kind of radical in the expression. Polynomial functions are a little bit harder to identify. You're looking for x to a power, and that power needs to be one of our whole numbers, 0, 1, 2, 3, and so on. But you can see it's pretty obvious in this one that we have a variable in the denominator, and that makes this a rational function. So we have a rational function. And we want to find the domain of this rational function. The domain is the set of all the x's, in this case t's, since that's the variable that we're using in the equation. So we're trying to find a list of all the numbers that we're allowed to substitute into this. We can only really come up with one problem, and that is with the denominator. We have a restriction that we're not allowed to divide by 0 because division by 0 is undefined. So we can find our restricted values, the numbers that we're not allowed to plug in, and then everything else will be allowed. So we're going to take our denominator of 5t squared, set that equal to 0, and solve. This is going to give us our restricted values. I would divide by 5. That gives t squared equals 0. I can square root both sides. And that gives me t equals 0. Typically we would put a plus and minus here, but 0 is neutral. It doesn't have a plus or minus sign. And so we have a restricted value of 0. So a restricted value is a value that if we substitute it into the function, we're going to get undefined. We're going to get something that is not defined. So this value is not allowed to be in the domain, but every other value is. So if I think about that graphically on the number line, 0 is restricted. I mark that with an open circle. Every other number on the number line is allowed. And we're going to write these values using interval notation. With interval notation, you write either parentheses or brackets, and you write down a lower bound, comma, and upper bound. So we're going to do that for this interval here. This interval, this would on the number line goes on forever in this direction. We label that as negative infinity to indicate that it's going on forever in the negative direction. The upper bound is going to be right here at 0. And then we want to represent this interval here, which is going to start with a lower bound of 0 and go to infinity. Then we use the set notation symbol of union, saying that together these sets make up the whole set. So our domain, all numbers from negative infinity to 0, union with 0 to infinity, and this set is all real numbers excluding that value of 0. Classify the given function as a polynomial function, rational function, or root function. Then find the domain. Write the domain in interval notation. Rational functions are pretty easy to identify. They'll have a variable in the denominator. Root functions are also pretty easy to identify. You will have a variable underneath a radical, like a square root or a cube root. And then polynomial functions are a little bit harder to identify, but they're the most simple type in that you will have x to a power, and that power needs to come from a list of nice numbers, or what we call whole numbers, 0, 1, 2, 3, and so on. So looking at our example, we have g of x equals the square root of 6 minus x. So it's pretty easy to notice that radical, and we would consider this to be a root function. And this is also very helpful in identifying the domain. Once you know that you have a root function, you know the type of restrictions you might have. Now, the root function, we need to further identify which type of root we have. You can either have an even root or an odd root, and that's indicating the index of the root. Now, the index is usually what's written right here as sort of like a superscript on the front of the radical. We call that the index. And with square roots, we don't write that index down, but the square root is an index of 2, which is even. So our example of having g of x equals the square root of 6 minus x has an index of 2, in which we would classify this as an even root. Now, the reason why that's important is because the even roots have restrictions on the domain. And the restriction has to do with negative values. So just for an example, if we have the even root of a negative number, the square root of -1, this gives I, which is not a real number. There is no real number that would make this true, square root of -1. So having a negative underneath the radical is a restricted value. And so that helps us find the domain of this function. So our restriction is that we only want the expression that's underneath the radical to be greater than or equal to 0. This will exclude all of the negative values, and then we will only get real numbers from those lists of what we plug in. So I'm going to take that expression, 6 minus x, create the inequality 6 minus x is greater than or equal to 0, and solve. So I subtract 6. That gives negative x is greater than or equal to negative 6. I'm going to divide both sides by negative 1. And with inequalities, when we divide both sides by a negative, we need to reverse that inequality symbol to maintain the truth of the statement. So negative 6 divided by negative 1 is a positive 6. And this is going to give us a set of values where this expression 6 minus x is greater than 0. So this will only produce real numbers when we substitute these values in. On the number line, I would mark 6 with a filled-in circle, indicating that 6 is included in the set, and I want to shade the values that are less than 6. I'll use interval notation to represent that interval. It's going to start at negative infinity and go to 6. I'm going to use a bracket on the 6 to indicate that 6 is included in the set. It's included in the domain. So the domain of this function is negative infinity to 6. Determine the interval or intervals for which the function is increasing, decreasing, and constant. We're given this picture, and we want to identify when the function is increasing, decreasing, and constant. So we need to know what we're referring to when we say these words, increasing, decreasing, and constant. And what we're referring to is what is happening with the y values, whether the y values are increasing, decreasing, and constant. And when we determine the intervals for which this function is increasing, decreasing, and constant, we're referring to the x intervals. So we look along the x-axis for the intervals, and we decide which intervals are increasing or decreasing based on what we see with the y values. So what I like to do is think about the big picture first, just to get an idea. And when I look at the big picture, I'm going to trace the graph going from left to right. So you want to find the furthest left on your x scale. And on our graph here, the furthest x is right here. And we're going to trace that, allowing the x's to get bigger. And as the x's are getting bigger, I can see that the y's are getting bigger. So I would say this section of the graph is increasing. The y values are increasing as I trace from left to right. And then it changes when we get to this peak here. And now as we trace, the y values are decreasing. And it changes again when we get to this valley, and now the y values are increasing. So let's label what we found. We found that this interval was increasing, and this interval was increasing, and this interval was decreasing. And remember, what we want to do is we want to write down the intervals for which it is increasing, decreasing, and constant, and those should be x intervals. So if we sort of project what we've labeled here, I should probably label this as increasing, decreasing, and increasing. If we project these highlighted regions onto the x-axis, I'm going to see that it matches up along here. So these x values represent the interval where the y values are increasing, along with these right here. And these intervals represent where the y values are decreasing. So I can use these scales, this x scale, to mark out the intervals of increasing and decreasing. Now it's important to note that it changes at this little peak here. So I want to pay attention to that x-coordinate. So this change we see would be happening at -5. And it changes here at this valley. So I need to mark out that this part where it changes is a 5. So this interval of increasing is from -infinity to -5, and this interval from increasing is 5, starting at 5, to infinity. And then our interval in the middle, that interval is decreasing, and that goes from -5 to 5. Now, in different books, they have slightly different definitions for increasing and decreasing. So sometimes you'll see the endpoints of your intervals included in the set, and so you might put brackets on it, and sometimes in some books, some definitions, you don't. So it really depends on which book you're using of whether you're going to include those endpoints or not. And I believe our book for college algebra does not include the endpoints. So we're going to say that this function is increasing on the interval from -infinity to -5, union with 5 to infinity, and you might actually just put a comma between that instead of a union. And it is decreasing on the interval from -5 to 5, and there are no intervals where this function is constant. Okay, so I've made a mistake here, and I'm going to correct it. So what I want you to notice is that the mistake that I've made is I was treating this picture as if there were an arrow on the end of it like this. So I wasn't being careful. So what we notice is that there is not an arrow on the end. We have the line coming to a stopping point. So our interval that I wrote here is incorrect. So it should be increasing only up to this x value that we see right here. So it really would stop around right here at an x value of 12. So let me erase what I highlighted down here. So this interval would go until 12 instead of to infinity because our end stops instead of having that arrow. So let's correct that. So this interval would be from 5 to 12. So this graph is increasing from -infinity to -5 and from 5 to 12 and decreasing from -5 to 5. On this question, we're given a picture, and we want to find for what values of x does the function obtain a relative minimum. Select the correct choice and fill in the blank. So we want to identify that we have a relative minimum and find out what value of x is that relative minimum. So the definition of a relative minimum is when we have a change from decreasing to increasing. So if we take a look at our graph, we can notice that the function is decreasing along this section, and then it changes to increasing along this section here. And when we have a change from decreasing to increasing, that creates a relative minimum at that value. So we have a relative minimum at this point, -10, -100. So the value of x, where the relative minimum occurs, is -10. Then we want to find the relative minimum value, and the relative minimum value will be the y value of 100. So the next part is asking the same type of question, but now looking for a relative maximum. With a relative maximum, we're looking for a change from increasing to decreasing. For the relative minimum, we were looking for the change from decreasing to increasing. So you can see here, if I continue tracing the graph, we have a change from increasing to decreasing that occurs at this value right here. And so that is a relative max. So you can also look at your picture and notice that this is a little valley or a little dip, and this is a peak in the graph, and those will indicate your minimums and maximums. It's valley with an E. So our minimum, the value of x where the relative maximum occurs, will be at 10, and the relative maximum value, that is the y value, will be 100. And I'm noticing here that my highlighting, my highlighting kind of obscured my vision of this point here. So I'm going to take the highlighting off, and hopefully you can notice that that y value is -100 and not 100. So I wrote this incorrectly over here. This minimum value is -100. And I put an extra 0 on that one there. Our maximum value is 100. Thank you for checking out my videos. Have a great day.